A force is a push or a pull between two objects that has the ability to change motion. Forces can cause things to accelerate in the direction of the net force. The units for force is newtons, and then if we were to break it down, that would be kilograms times meters per second squared. And where does that come from? If you recall back in like 7th grade and 5th grade and maybe back to 3rd grade, that force equals mass times acceleration. And that would be synonymous with newtons for the force, mass in kilograms, and the acceleration in meters per second squared. Force is a vector, which we know has a magnitude and a direction. So we have to specify which way it's going, and we have to say the amount. Whenever we refer to net force, that squiggle F or sigma F means net force. That's the total forces acting on an object. This is also called the resultant force. To get the net force, we simply add all of the forces up that are acting on the object. Something to remember is that if they're going in opposite directions or different directions, you have to take direction into account. So sometimes you can't simply add them or subtract them. An example here for you is of a long vector that then was the result of adding all 4 of those smaller vectors. And something I wanted to remind you, whenever you see sigma F, that refers to the net force, which is the sum of the forces, and it's also called the resultant force. Force diagrams are pictures that have vectors or magnitude and direction to show all the forces acting on one object. For instance, here we have a table and a book just sitting on that table. What always pulls down on an object? On Earth, we have the gravitational force. And then the table will push back up on the book, and we call that the normal force. The reason we call that the normal force is because it's a force that is perpendicular to the surface, and it is a contact force. So whenever you have a surface, that surface will push back up on the object that at a 90-degree angle. The weight, also called Fg, also called the force due to gravity, is the force that the Earth exerts on the object. That'll always pull straight down towards the center of the Earth. In this case here, with this example, Fn and Fg are said to be balanced. Now moving on to vector addition, and you guys have seen this before. If we, for instance, have 5 newtons and 10 newtons both pulling to the right, our resultant force or our net force would be 15 newtons to the right. Notice that we quote not only a magnitude, but we quote a direction as well. Secondly, we have 10 newtons pulling to the right and 5 newtons pulling to the left for a net force of 5 newtons. So notice if they're going in the same direction, we add. If they're going in the opposite direction, we add the negative. And then lastly, if they're at a 90-degree angle to one another, like our 3 newtons and our 4 newtons, we pythag it up. We're using the parallelogram method to then give us 5 newtons. Balanced forces is exactly what it sounds like. You have the total forces on one side equaling the total forces on the other side. That then gives us a net force of 0 newtons, which means that there's no change in motion, aka no movement or constant velocity. It depends on the initial state of your object. If the forces are balanced, the net force is indeed 0. And then that therefore means that the object is either at rest or going constant velocity. I added this little graphic for you to be able to say to yourself, like, okay, are the forces balanced? Yes, they are. Then that means we have no acceleration. And that means we could either be at rest or in motion at constant speed. And then there's an example down